Hello, and welcome to the Energistics webinar on the value of standards. My name is Nicolette Ross, and I will be your moderator today. I would like to start the session with a few housekeeping items. For audio, you may use either your telephone or a mic and speakers. Please note that all attendees are muted. At the end of Ross's presentation, we will have time for questions. You may submit your questions throughout the session by using the Q&A section of the session toolbar. If we do run out of time, we will try and follow up on all unanswered questions. This webinar is being recorded and will be available on the Energistics website within 48 hours. You will receive an email with that link. For your convenience, we have the presentation slides added to the session toolbar under Handouts. You may download them anytime during the session. At the end of the webinar, there will be a very brief survey to let us know how we did. We would appreciate you taking the time to provide feedback. Before I introduce Ross, we have a couple questions that we would like to ask to find out a little bit more about you. Here's our first question. Is your company a member of Energistics? So please select yes or no, or if you're not sure, select that option. And there's our results. So as you can see, most of the attendees on the phone today are members of Energistics. There are a few that are not. Okay, we have another question. Our next question is, which Energistics standards are being used by your company? Please check all that apply. Okay, and there's our results. So most people on the phone are using WITSML, but there's also quite a bit of RescueML, ProdML, and ETP. Great. Thank you for answering our questions. We appreciate it. Now I would like to introduce Ross Philo. As President and CEO, Ross provides the leadership for Energistics to achieve its vision and mission for the development and adoption of the data exchange standards for the oil and gas industry. Responsibilities include strategic planning, operations and financial management, communication and public relations, strategic alliances, building an inclusive global user community, and facilitating a collaborative standards development environment. Ross has over 35 years of experience in the oil and gas industry, and he is a member of the Energistics Board of Directors as well as a member of the Standards Leadership Council. Welcome, Ross. I'll now turn it over to you.
Thank you very much, Nicolette, and hello and welcome to everybody on the call. Thank you very much indeed for taking the time out of your day to listen to this webinar. Let's hope that we can cover some interesting stuff. But before we start and talk about the value of standards, I think we should address the question of whether we actually need data transfer standards. It's all very well to talk about adoption and value, but do we really need them? And I think it is absolutely fundamental that we have got data transfer standards that manage the communications between partners, between users and applications. Data flows are really just like traffic, and you can see in that left-hand picture the sort of chaos that can ensue when you have no rules of the road. Not only is it inconvenient and obstructive, but it's also a safety risk. Data standards in the same way facilitate collaboration, they help reduce costs, they make sure that the data traffic keeps flowing, and so without those sorts of rules you're going to get the equivalent of data road rage, rather like the guy on the right-hand picture sitting in that traffic jam, pulling his hair out. You can imagine the sort of challenges that very many data users have when they are presented with a set of data that requires significant time and effort to validate, to correct, before they can start doing their work. You know, standards are with us in every aspect of our lives. This pictogram is courtesy of ANSI, and it shows just 75 of the several thousand of ANSI standards that basically impact our lives on a day-to-day basis. And there's some really interesting ones here. I'll just give you a couple of highlights. There's one that clearly I think we would all be happy to know about, is the effective sterilization in healthcare settings. Obviously, you know, if you go to your local hospital, you want to know that they are following those sorts of rules. There's another one about the protection of sensitive payment card data. Again, that's an ANSI standard. There's a standard on the operation of nuclear plants. Lots of things that really touch our lives every minute of the day. And I think for most of us, you know, standards is one of these things where we all agree that they are good. They aren't necessarily particularly sexy, but they are absolutely essential for the smooth running of our entire community as well as our daily lives. So let's talk about the different sorts of standards that exist out there. There's three major categories: de jure standards, de facto standards, and consensus standards. And de jure, as you might guess, means that they have been mandated by law. You have no choice but to do it. And the examples on the left-hand side actually show a couple of examples there of de jure standards. The one on the top left is really quite famous, and the two photographs show the scene above and below at a point in time in Sweden in September of 1967, when the government mandated that people would stop driving on the left-hand side of the road and start driving on the right-hand side of the road. Just imagine the chaos that could ensue if that wasn't properly handled. But it was, you know, being Sweden, this was incredibly well handled, well planned, and at sort of 5 a.m. in the morning on the 3rd of September 1967, they said everybody has got to stop driving on the left-hand side of the road and move over to the right. And if you look closely at that top picture, the very top left, you can see that the drivers are actually on the left-hand side of the car. So they really should be driving on the right-hand side as far as the setup of the steering wheel is concerned. The image on the lower part of the picture is that same view with the cars now driving on the right. Incredibly important, well handled, mandated by law. Another aspect of legal standards that impacts us is the everyday controls on food and health safety. So there are labels that define exactly what sort of nutritional content your food has. More importantly, when you look at the very bottom of that left-hand side, there are the food freshness controls. You know, how long can food be displayed, what sort of temperatures should it be displayed at, and whether or not it has an inspection to prove that it is good consumable food. Clearly protects our health. The middle section of this slide shows some de facto standards, and typically these are where you have a particular company that achieves such dominance in the marketplace that for simplicity of its end users and the general business community, these have become an accepted, a de facto standard where alternatives still exist, but by and large these have become the usage of choice for the majority of end users. And obviously we're all familiar with the top one, Microsoft Excel, part of the Office package. There are still some very, very good alternatives to that, but by and large, if you want to live and work in the business world, you're going to be using Microsoft Office for exchanging information. The middle one, the QWERTY keyboard, has been around for, I imagine, over 150 years from the early days of the typewriter. And in fact, it's got an interesting history in that it was developed in order to slow typists down. The idea here was that by looking at the layout of the various mechanical keys on a typewriter, you wanted to slow a typist down so that the keys didn't risk jamming with one another. So it's ironic that the keyboard layout is actually standardized in such a way as to try and slow you down. Of course, these days we don't have those same mechanical keys, but the layout persists. There are, again, alternatives. The famous Dvorak keyboard was one such, and there are obviously regional variations to allow for different languages, but the QWERTY keyboard is no doubt a de facto standard. Just as Adobe and the PDF format is for exchanging documents. And one of the things, as that picture at the bottom shows, is the ubiquitousness now of cell phone standards. If you think back to the mid-90s, how difficult it was to be able to travel the world and be able to have good connectivity. These days we can fly anywhere in the world and know with a pretty high level of confidence that our cell phones are going to work. Absolutely essential, but it requires standards to get there. The third section of this slide talks about consensus standards. And this is where you have either a private or a public group of experts who get together to thrash out exactly what a standard should look like for some commonly required item, process, development issue, or what have you. And so things like programming languages, C, Fortran, things like that are the result of very intensive discussions and collaborations either between professional bodies or even at a governmental level, as is ISO. And the Energistics standards fall into that third category. There are 3 standards, one covering drilling, one covering production, one covering reservoir information, but they are defined by a consensus model. So the subject matter experts within our various member companies get together as work groups in a completely antitrust compliant manner in order to discuss and define how these standards should work for the benefit of their company and also for the benefit of the industry. So these are truly defined by the industry and for the industry. And we'll talk in a little bit more detail in a moment about what those 3 standards do. There are many other standards within the oil field landscape. So for instance, you have SEG that oversees the seismic standards. You've got Mimosa and USPI looking at facilities and maintenance, OGC for geomatic, PCA for facilities along with OPC, PODS for pipeline, and so on. It's a very rich landscape, but there is collaboration between these different standards groups in order to make sure that there are no gaps as well as no overlaps, and I think that's one of the things that, that Energistics obviously takes care of on behalf of our members. I like this image. I think it's a really good way to try and visualize what standards can mean for us. So when you've got an orchestra and you have the sheet music in front of each of the musicians, it's important that they are all interpreting that data, interpreting the music in a standard manner. You can just imagine the cacophony that would exist if everybody decided to look at the notes on the page and interpret them completely differently. The E&P industry is very much like that orchestra. There's a whole group of different players. You have the operators, partners, you have E&P service companies, you have software developers, systems integrators, regulators, all of whom are playing together. And the value of standards is to ensure that data can be moved easily and effectively between companies, their partners, between software providers or software gatherers sending data to their clients, between users within a company as well as users across different companies. And very clearly that presence and usage of standards means that you eliminate complexity, you eliminate uncertainty, and you reduce cost and save time. So I think that visual image of an orchestra and the players in it is a good analogy for our industry and the players within that industry and the ability to essentially share data, make music, make money, who knows, but that's the value of standards, and I think it's a good mental image to take away. So I mentioned we have our three standards, WITS-ML, PROD-ML, and ResQML. They've been around now for many years. In fact, Energistics has celebrated its 25th year just last year. So these standards have a very long track record. They have become extremely well respected within the industry and are by and large the only standards out there to do the tasks that have been asked of them. And as I mentioned before, they are defined by the industry and for the industry through the subject matter experts in our different work groups and known as SIGs, special interest groups. The focus of them is very clearly defined here. So drilling covers anything to do with wellbore and drilling related data, as I imagine most of the listeners on this call will already know, since you've said that 70% of you are members of Energistics, so I'm to some extent preaching to the choir here. Production is production-related data, as you would understand, so that's covered by PROD-ML, and ResQML looks at the Earth model, everything within the Earth science workflow from seismic through to simulation within the geoscience workflow. And one of the things that we have undertaken in the last 2 years with the help of our members is to define a common technical architecture that now underpins each of those three standards. They all came from three very different origins, but now with that common technical architecture, that underpinning means that the data objects have been standardized and are far more consistent. And that actually means that you've almost got a continuum of data objects from the drilling side through to the reservoir side that allow you to pick and choose which data objects you wish to consume. Which could mean that if you as a consumer wanted to pull information about the well trajectory from WITS-ML and production information from PROD-ML, as well as perhaps horizon information from ResQML, you can now do that because of that common technical architecture that underpins it. So let's talk about the value. And that's the main focus of our conversation today. And I've picked out a number of key points here that I'll go into in a little more detail in a moment. But for me, one of the key things here is the concept of reducing what I call data friction. And the image on the right-hand side is essentially, a spider's web. We all recognize that. But again, this is a really good analogy for the ecosystem within which we work in E&P. So for instance, imagine that you, an operator, you're the center of that cobweb, and the links that go out radiating from that center point in the cobweb are to your partners, to your service providers, to other people and companies within the oil and gas industry. And you can imagine that if those links are managed on a point-to-point basis, you are going to have all of the complexity that a cobweb represents. All of those point-to-point solutions have to be developed, they have to be maintained. When one of them changes, there may be knock-on implications for others. So whether this is companies talking to their partners, whether it's companies talking to service providers, or whether it's application talking to application, data store to data store, you can end up with a completely complex myriad of these interfaces. And in fact, in a recent conversation at PNEC, I was talking to a representative of a major oil company who said that they have 4,000 interfaces that they have developed and have to maintain in order to move data around. I'm not suggesting that Energistic standards could replace all 4,000. Clearly that would be an unrealistic goal. But certainly if you can build a standards-based interface, build it once, develop it, and reuse it multiple times, you can eliminate much of the complexity within the current ecosystem. When you've got good standards, the consumers know what to expect, the data can be brought in, and you eliminate a large amount of errors. We'll talk about that in the next couple of slides. And certainly when you look at the amount of time that is involved in correcting those data errors or simply validating the data that you have received, you are going to reduce non-productive time. I'll talk about data quality in a moment, and I've specifically put here that the standard informs data quality. It doesn't guarantee it. You can have data that conforms to a standard and can still be bad data. I mean, the quality of the underlying data is not corrected by the standard, but it can be informed by the standard, and that's a really important distinction. And I think we have the opportunity to say that if you've got highly technical people within your organization and you can present those technical people with trusted, validated data, it enables them to really focus on their creativity and their technical skills that can ultimately mean that they are getting on with their job faster and with greater confidence, essentially driving that innovation that you need in order to deliver results to the bottom line. And then finally, we shouldn't forget safety. Safety is paramount in the oil and gas industry, and when an incident occurs, you've got to have trusted information readily at hand that you know comes from a known source and is in a quickly a usable format in order to be able to respond to whatever incident you have. So let's look at these in a little bit more detail. Data friction. I mean, I think it's a great term. The idea that you're trying to move data from point A to point B, whether that's between companies or people or applications or data stores, and you've got a very broad range of services and technical solutions there. You don't want anything to slow down the movement of that data. It is literally like sand in the machine to have problems that occur that are impeding the rapid flow of that information. Your partners need a consistent view of the data. An ability to share data between operators and partners is essential. Standards make that much more easy, much more consistent, much more reliable. Similarly, regulators require consistent reporting. They need to know exactly what productions you're producing on a monthly basis, and our standards are being used by some regulators, being insisted and mandated by some regulators as a way for operators to report their monthly volumes. And as I've been saying before on the previous slide, when you have these standards in place, you can move data in a consistent and seamless manner, whether it's between your applications, whether it's from the rig to the shore, whether it's between employees and so on. And a key use that we're beginning to see more and more of is the ability to rely on standards to bring in data, legacy data, that if it had been stored in a standard format, allows you to reanalyze that with a more modern application. If you think about much of the legacy data that was perhaps created back in the 1990s, if you wanted, without a standard format, to be able to go back and reanalyze that data from a particular field, you would have to recreate the hardware and software and application environment that was around at the time. And you can very easily recognize that that is an incredible challenge to try and recreate an environment of hardware, software, operating systems and applications from the 1990s when here we are in the mid-2010s. So one of the things that we're beginning to see companies show a great deal of interest in is the idea of saving data in a standard format, an Energistics-based format, so that it can then be re-ingested and reused, because ultimately oil companies are spending a fortune in gathering this data. We need to make sure that it can live on and be reanalyzed if necessary in the future. We talk about lost time, and you know, there's some really good examples that you may have seen before in previous presentations that Energistics has made, but this particular one is really very illustrative of the problem. We're all familiar with the sorts of images of an Earth model section as presented on the left-hand side of the screen. But what would happen if, when you import your data, Instead of the rather nice presentation on the left-hand side, you end up seeing something on the screen that looks like that. Absolutely corrupted information here that is going to require a great deal of time and diligence to correct. And in this particular example, although the horizon information was correct, there was some data where the depth references were going negative into the well as opposed to positive, so we had sign conventions that were completely incorrect. We had differences between the Windows and Linux binary formats, as well as a whole load of information around the trajectories. And as it said there were 200 wells that were being analyzed, and the data had to be corrected. It would have taken days, if not weeks, to actually get that data corrected, a problem that could have been avoided had standards been used correctly and consistently when the data was being transferred from its original source. And you know, coordinate errors can be absolutely dramatic. If you have got errors in your CRS, your coordinate reference system, it is not unlikely that you could end up drilling a well some 500 to 700 meters from its desired location. And you can imagine the consequences of that when you're considering the type of subsurface prospect that you're drilling into. And indeed, we have heard from one member of a case where, because of coordinate errors, 3 different well locations were identified. A well was drilled at each one of those locations. In fact, they should have been exactly the same location. The net result was that that well was essentially drilled 3 times over at roughly a cost of $18 million per well, resulting in very, very significant financial impact, as you can see. And there's one very, very famous case that you may have heard of back in the November of 1980, when a Texaco drill rig was incorrectly positioned. It thought it was in a particular location. In fact, the trigonometry was wrong. It was slightly offset from its desired location, and the drill ended up penetrating an underground active salt mine, with the net result that the entire lake drained into this salt mine. There was something like 11 barges that got sucked down into the maelstrom as this thing, basically rather like a massive sink, was draining through the plug hole that the drill bit had created. It was an active salt mine. There were people in the mine. Luckily, they all managed to evacuate safely according to their safety protocol, so nobody lost their lives. But it was a massive disaster. And so one of the things that Energistics is very proud of is that we comply with EPSG standards in terms of coordinate systems, and Energistics is responsible for managing units of measure on behalf of the industry. So many of you may have heard of this famous paper. It was actually published back in November, excuse me, November of 1991 by Lee Sawyer, who was at the time the chief geophysicist for Chevron. And in it he had analyzed the time spent by geophysicists and geologists before they can start work. And he came up with a statistic which has become almost apocryphal within the industry. He claimed that geophysicists and geologists spend 60% of their time looking for data. This was back in 1991. And in conversations that I've had with a number of our members and other operators and so on, I've challenged this, and I've said, you know, is this true? Surely these days we don't spend time looking for data as much as 60% of the time. So is it truly a myth, or is it does it still have some validity? Well, intriguingly, in last week's PNET conference here in Houston, one of the presenters showed the results of a benchmarking study that was done on behalf of Repsol, and that included comparative data from 10 other major E&P companies. And the results are actually quite remarkable. It depends very much on the maturity of the data management skills within the company, but by and large, the time lost in validating, preparing, and correcting data before the interpretation work can begin varied from 35% to 70%, and in some cases as high as 90% for some tasks. So if you look at that and you think about a broad average, you could very definitely say that that 60% rule is still very much alive and well, not necessarily looking for the data, but in preparing the data before the real work can begin. And let's just think about what that 60% means in financial terms. That's 3 days a week for a geoscientist or a data analyst to spend correcting and validating and preparing the data before their interpretation work can start. Almost 5 hours a day. Incredible statistic, but borne out by this recent benchmark study, which again confirms that earlier paper by Lee Sawyer. So 3 days a week, 5 hours a day. What if by using standards you could save 2 out of those 5 hours? So assume a fully loaded cost of about $100 an hour, 2 hours a day, 5 days a week. The guy's got to take 4 weeks vacation, so we're going to multiply that by 48 weeks. You end up with those 2 hours a day saved through the use of standards, potentially representing $48,000 savings per person per year. And in a company that perhaps has 500 geoscientists and data analysts, that would translate into $24 million a year of potential savings. Now, in today's environment, obviously every company is looking for cost savings. I would actually suggest to you that because of the reductions in staff that we have had as a result of the downturn, right now it's actually more important to say there are fewer people trying to do the interpretation work and the data analysis work. So whilst the savings, the potential savings are truly significant, I think it's more important about leveraging the talent that you have in order to make sure that they are focused on value-added tasks rather than the mundane task of assimilating and assembling the data ready for interpretation. Allow your staff to do the high-value work rather than the data aggregation, even though those dollars are obviously going to be significant and would catch the eye of any CFO. I talked about the concept of informed data quality, and one of the things that Energistics Standards has is a data assurance object. And again, as I mentioned briefly in my introductory remarks, it doesn't mean that the standard is validating the data per se and saying this is good data or bad data. It is allowing the data to be checked by the sender against a set of predefined business rules that may indeed be part of the contract between the data provider and the company that is consuming that data. So by having these rules in place and by checking the data against those business rules, for instance, you know, that a well must be surveyed within 30 days of completion date. Those sorts of data, the sort of data ranges that may be in place in order to establish bounds for particular types of data. The sender of the data can say to the consumer, I have checked the data against the business rules that you required, and I can essentially certify that it meets or beats those defined business rules. So the consumer now has a way of judging the trustworthiness of that data. It could still be crap data. Don't misunderstand me here. But nevertheless, the user has a way of saying, it has passed the rules that I set for that data. I now know that I can approach this data set with a higher level of confidence about how good or how bad it may be because of those data assurance checks. And then finally, we talked about safety. It's certainly not the last thing on our minds, it's the first thing on every company's mind in the E&P sector. And when something goes wrong, you need to have accurate information, you need to have timely information, and it needs to be trusted. It is no good when somebody has an issue offshore and is looking for schematics or looking for information that it's locked away on somebody's laptop, potentially out of date information, not accurate, and not accessible if the person whose laptop it's on isn't available at the time. So data standards can ensure that you have the right information at the right time and could potentially save lives, which is absolutely fundamental in our industry and obviously of critical importance. So let's try and quantify the value. We've mentioned the sorts of savings that could be implied by just saving 2 hours a day of data analysis time when you're assembling the data and validating it. If you could just save that, we showed that it could add up to something close to $50,000 per user per year. But we can also look anecdotally at a number of the reports from our members. Some have reported saving as much as 2 to 4% in non-productive time since adopting WITS-ML. Over the course of the year, that could add up to the cost of 1 well, possibly 2. Other members have reported saving tens of millions of dollars in terms of avoided software development, improvements in operational efficiency, and elimination of errors. And again, I would refer you back to the example that I said at the beginning where one major oil and gas company mentioned that they have 4,000 interfaces that they had to develop to maintain and modify as software evolves. A huge task, a huge implicit cost as well. And I think ultimately, we have to recognize that the data that is being talked of here truly is a key asset for the E&P company. Companies have spent billions of dollars acquiring it and processing it. The use of standards maximizes the value of that asset by ensuring that not only can it be used, but also that it can be reused. And ultimately it means that if you've got better standardized data, you're going to make better informed decisions, and also your staff are going to be able to on much of the knowledge that they have imparted onto that particular interpretation to the next generation. Therefore, you get better knowledge retention within the company. But as I put right at the top of this, to actually get hard numbers is indeed hard, because a lot of this information is obviously commercially sensitive. We are not going to get our members to say that they saved X million dollars directly in a paper, but I can at least report the sort of anecdotal information that I think informs this conversation. So to begin to wrap up here, I think we've seen that standards can deliver cost savings not just for individual companies, but also for the industry as a whole. And the fact that these standards have been developed by the industry and for the industry means that they are truly in the interests of the entire industry segment. And I think one of the focus areas that we have, as Nicolette said in her introduction, is to try and drive adoption of these standards for the benefit of the industry. As a non-profit organization, we are funded by our members to help facilitate the development of these standards, but there is no commercial interest in it for us. We are doing what we do, supported by our members, for the benefit of the industry. But with those standards in place, you can ensure that data can be exchanged seamlessly and with complete fidelity between users, between companies, between partners, between service providers, and with regulators. And I think we've seen in a couple of the slides here and the examples that I gave you of what things can go wrong when you have bad data, that if you can trust the data that you have, you're going to avoid wasted time and data correction. You're going to have increased productivity. You'll have better informed business decisions and potentially faster innovation by allowing your scientists to focus on what they do best. We've talked about eliminating that lost time, resolving data quality issues, and in particular this concept that when you have a standards-based format for archiving your information, you can subsequently import that with complete fidelity into a future application model. So you're essentially future-proofing the data and the value of that data that you've spent millions and billions of dollars acquiring and processing historically, bringing it forward for reassessment and reanalysis should you choose to do so. And as I mentioned, we must never forget safety. So safety is paramount for the industry. You've got to have rapid response, and to respond quickly and appropriately, you need to be well informed and have information about the situation so that you can actually respond to the challenges that are presented by whatever the incident may be. So I think, in summary, we're advocating a consistent message to the industry that standards save time, they increase efficiency, reduce lost time, reduce complexity, and can potentially help save lives. I think we've seen very clearly from the some of the proposed and potential savings that the business value is absolutely clear and compelling. We may not be able to publish papers on hard data, but just some simple back-of-the-envelope calculations show the potential savings by eliminating the data errors, eliminating data validation and formatting problems, and also by being in a position to have more trusted data and exchange data more effectively, eliminating all of this myriad of interfaces that would otherwise be potentially simplified. And to that diagram that I gave you before of the cobweb with all of the interfaces, the use of Energistics standards truly does allow you to blow away that cobweb, simplify it, get rid of so many of the point-to-point solutions, and focus your company on what you do best. Now, I obviously, I'm passionate about this topic, even though, for most of us, standards may not be a particularly sexy topic, but they are absolutely critical. You've seen from those early slides how they impact every aspect of our lives. And so I think one of the things that we're trying to communicate to the industry and to try and attract non-members to our group is that they are exactly what the industry needs in a downturn in terms of delivering those savings and essentially leveraging the standards that the industry has developed across a much broader population. WITS-ML these days is pretty much ubiquitous on any offshore drilling operation. We are now moving on to try and drive that same level of adoption across ResQML and ProdML, and we're beginning to see some very, very good take-up there. So that is where our focus is very much in place this year and next, with an equal balance, I would say, between development and adoption. 2016 is going to be an absolute milestone year with new releases of all three standards, all taking advantage of that common technical architecture to allow a consumption of data objects across that continuum of data standards. So with that, I will thank you for your attention. I really appreciate you taking time out of your day. I'll hand it back to Nicolette to take and discuss any questions that we may have had. So again, thank you very much indeed.
Thank you, Ross. Now it's time for the question and answer portion of our event. As a reminder, you may submit your questions by using the Q&A section of the session toolbar. Okay, here's our first question. First of all, thank you for this great presentation. What about the savings in developing standards mutually across companies rather than solely within a company? I believe this mutualization is saving on specialist time and adjustment to external standards once they are finalized.
I think that's a great question. Clearly, Energistics, with its very small staff, is not in a position to develop solutions, software solutions, on behalf of a particular company, but the idea of mutual development between interested parties is absolutely something that I think is worth exploring. And obviously there are also service companies and software companies who, by developing Energistics standards-based solutions, are in essence providing that to the marketplace to a broad range of companies. Some E&P companies, of course, have their own internal development staff. Others rely on software that does come from the sort of software developers that I just mentioned a moment ago. But we would certainly be in favor of any mutual development in order to help drive adoption and potentially spread the cost of software development depending on the particular software environment within which it was going to work, because obviously that may have some localization that makes it difficult to adapt to a general solution. But the concept is certainly one that we would encourage. Thank you.
Thanks, Ross. Our next question. Indeed, this is a great presentation. We still see some resistance to adopt the ResQML and ProdML comparing to the WITSML. Any action points that are planned to address this challenge?
Yeah, that's again a super question, and indeed it speaks to some of the activities that we've been focused on very attentively for the last several months, given our shift now from development into more of a balance between development and adoption. And we've had absolutely fantastic take-up by the ResQML SIG, for instance, the working group, about the challenge of adoption. They have really taken this on board. It has been part of the discussions that we've had at the ResQML iLabs, where the various members of the work group get together to discuss some of the challenges both of the standard and how they want to see it evolve in terms of new functionality, as well as the needs and the demands of trying to broaden adoption. And so we have a number of activities that are focused on that. We are looking for some pilots, potentially multi-client, multi-vendor pilots that would enable us to demonstrate the savings and the value of adopting ResQML. Ideally, what I would like to get to is a point where we build on the success of WITSML and the way that that has become ubiquitous to show how we could then move on and drive ResQML to be equally ubiquitous. And I think there's a couple of areas where ResQML clearly has some tremendous advantages over existing tools that may be within the various companies that use it. Ultimately, however, one has to recognize that this is all about changing workflows. And in many companies, there are geoscientists who are still relying on the original ResQ format, along with a number of additional ad hoc tools to try and do the data management that they require. ResQML, particularly in its latest version, completely blows away the need for ResQ and all of those add-on tools and can provide a single consistent solution. But we need to be able to demonstrate the value of that solution, and I think these pilots that we are currently discussing with the ResQML SIG, the special interest group, and the member companies to try and put that pilot together, I think it's that sort of thing that will help us really raise the visibility of the benefits of ResQML and drive companies towards gaining those savings by updating their work processes and getting rid of outdated and potentially unique and proprietary tools that are hard to maintain and manage. But ultimately, that's where the ResQML SIG is really helping us. They are incredibly engaged, and I really want to take my hat off to them because of the effort that they put into trying to communicate the story around ResQML and help us drive adoption further.
Okay, thanks, Ross. Next question. Do you know of any effort to write an XML standard for AGA data?
I do not. If somebody is interested in pursuing that, I would suggest they send an email to Jay Hollingsworth, who is our Chief Technology Officer. So it's j.hollingsworth@energistics.org, discussing exactly what the idea would be behind it. We are always open to suggestions around handling new types of data, and in fact the ProdML SIG developed on the request of a couple of our member companies, adopted some new data objects to cover some of the new fiber optic type sensing. So distributed temperature, distributed acoustics. So those data objects have been defined and are now part of the ProdML XML standard. And in a similar way, you know, we see evolution of the other standards to cope with and cater for new types of data. In the past, we've also had a work group that focused on microseismic. That work was done in collaboration with a number of microseismic vendors. So the concept of us working with the industry and working with interested parties to evolve the standards or to address a particular new standard that might be required is very much you know, in our character, because as I said before, we are working on behalf of the industry. So if the industry has an interest in developing a particular standard to address some new data type, then if there is a sufficient interest and a consensus can be put together, a work group can focus on it with representation from interested parties, then we would be very happy to facilitate that. So it's very much a question of, you know, ask, build an interest group, and look at what the potential uptake would be in terms of that particular data type. So as I say, for the person interested in AGA, reach out to Jay Hollingsworth and have a conversation about how common a requirement it might be, and who could be involved in terms of providing the subject matter expertise to help drive it towards a specification. Thanks.
Thanks, Ross. Next question. Thanks for the presentation. How can you help independent companies to develop new software? Is there free data to test any software?
So one of the things that we have started this year, which is proving to be very, very interesting for a number of companies, is a series of training classes that we have put on in order to help independent companies as well as larger organizations understand the standards better and understand how to develop solutions around those standards. And so far we've done a number of in-house training courses. In fact, Jay Hollingsworth is away today at one of our major members providing a 2-day course focused on ResQML. And so one of the things that we do with these training courses is to tailor them to the specific needs of the requesting organization. And so if somebody is interested in developing a ProdML solution or a ResQML solution or a WITSML solution for that matter, or to understand how to implement the new Energistics transfer protocol to really improve the real-time streaming of data, we can tailor a training course specifically for that. And I would encourage you to either reach out to myself or to Jay or Jana if you are interested in taking advantage of that. We have also done a public course which is more generalized, and we had some very good attendance at the first of those public courses back in January of this year. But I think when it comes to helping a particular company develop a solution, then having a focused course in-house is the thing that makes most sense. In terms of data, well, we do a couple of things there. Firstly, we do have a certification process for WITSML servers where a company that has developed a WITSML server can have it certified by us. and that's a well-established process. And we are moving more and more towards putting together good sample data sets that companies can also use to validate that they are bringing in the appropriate data, exporting it in a standardized format that it can then be consumed and is correctly interpreted by the consuming application. As you can appreciate, getting data is actually quite a challenge, and I'm particularly grateful to Statoil in that regard, who've been able to release information related to a group of 6 wells with a whole bunch of drilling information. Many of the data sets that we do get are restricted to our members in that they cannot just be made publicly available, but that's the terms of the release from that company that owns the intellectual property and is unable to just publicly release them. But we're also working with a number of regulators to see if we can get further data that could be in the public domain that would also help that. So hopefully as we move forward, we will get to a situation where we have both rich data sets for our members and potentially other data that could be publicly shared. But it's always a challenge to get comprehensive data sets because, again, it's commercially could be commercially sensitive. It needs to be made anonymous. It needs to be presented in a way that can be easily distributed. Ideally, what we would like to get to is to a point where we would a comprehensive suite of data that represents a given field, right from the early seismic all the way through production information and reservoir modeling and so on. But as you can appreciate, putting those sorts of data sets together, whilst it's certainly high on our list, it's a continuing process to try and make progress there. Thank you.
Thanks, Ross. Our next question. Will WITSML 2.0 address some of the operational headaches with current standards, specifically scalability and support effort required?
WITSML 2.0 introduces a number of revised data objects, and some have also been deprecated because they are no longer used. The fact that it is based on the underlying common technical architecture, I think, gives it tremendous advantage over previous versions. Most importantly, WITSML 2.0 takes advantage of ETP, which is the Energistics Transfer Protocol, and this is something that we are truly excited about because ultimately it means that you could eliminate the servers that are involved and essentially consume data direct from the sensor to the squiggle, if you will. And the improvements that we are seeing in terms of reductions in latency suggest that this is going to be a dramatic change that will lead us towards true real-time streaming of information from the rig site to the office, with all of the implications that that provides in terms of, you know, instead of waiting 60 seconds, for instance, for a real-time piece of data, if you could get it in less than 10 seconds, your ability to respond to that information for whatever reason is obviously enhanced. So I'm hoping certainly that the 2.0 is both going to be easier to maintain as well as offering a much broader range of capabilities that the members of the WITSML SIG believe are of particular importance and benefit to the industry.
Okay, thanks, Ross. I think we've got time for one last question. Will the Repsol paper you mentioned in slide 13 be available to the general public? I could use it right away.
I will take that as an action item to approach the PNEC conference as well as the company who undertook the study on behalf of Repsol. I'm not sure if the underlying information would be published. I do know that, as I mentioned in my remarks, Repsol funded the study and invited 10 other major companies to participate by providing information about their own data maturity, data management maturity within their companies. And in turn, they then benefited by getting the data. But I'm not sure if it's a paper that is going to be available publicly in detail, but the summaries and the findings were certainly discussed at PNEC, and I imagine that that level of information could be shared publicly. But I will take an action item on behalf of the question to look into that, and we can then come back to the user community and let you know.
Great, thanks, Ross. Well, unfortunately, we've run out of time. We still had a few questions that we weren't able to get to today, and we will try and follow up with everyone that had a question that didn't get an answer. Just to let you all know, later in the year, we will be hosting webinars on ProdML, ResQML, and ETP. So watch your inboxes for more information. Thank you for spending this hour with us. We hope you found it informative and hope you have a great day.
Thank you.